Okay, so we're going to form a composite function, and then we're going to find that composite function's domain. So you've been given two functions, f of x and g of x, both of which happen to have domain restrictions because they both are rational and have an x in the denominator. So the first thing I'm going to do is find the domain restriction for f of x. So since it has a denominator, remember, I have to set the bottom not equal to 0 because I don't want that bottom to go to 0, which means if I'm dealing with f of x, x cannot be 1 because that would make this an undefined function. So I'm going to do the same thing for g of x. This one's very simple. I just set the bottom not equal to 0, which means for g of x, x cannot be 0 because that would make this an undefined function. Now let's go ahead and do our composition. So this notation f, sometimes we call it fog, F-O-G, this is the same notation as f of g of x, which sometimes is easier to read. That means I'm plugging g of x inside f of x. So in this case, it's going to look like this. This is going inside of this. So I'm going to write it in the other color that I was using before. This is g of x, and this is f of x. So I'm going to write that is my composite function. However, it needs to be simplified because right now I have what's called a complex fraction. I have a fraction inside of a fraction, so I need to get rid of that. In order to do that, I'm going to multiply by x over x, which of course is just 1. Technically doesn't change the fraction any, but it is going to simplify this for me. I end up having to distribute the x. Remember, on the bottom it'll be distributed to both pieces. So it simplifies to 2x over 3x over x minus x. This x over x cancels, which is exactly what we wanted to happen because that has simplified my fraction now. And I end up with 2x over 3 minus x. This is my new composite function. And now I need to find the domain restriction here because when I made my composite function, it also happened to be a fraction. So I've got to find a domain restriction there. So I set the bottom not equal to 0. This time I'll move the x to the other side, and I end up with x cannot be 3. So I have 3 things that x can't be, but I need to check each one of them because it's possible that because I'm making a composition of the functions that one of these might actually work. So I'm going to do exactly what we've done here and plug it in just like this. So I'm going to start with the first one I came up with, which is the 1. And because this is my notation, the first thing I'm going to do is plug the 1 into g of x. So that's going to be 3 over 1, which gives me 3. And now I'm going to plug that into f of x. So 2 over 3 minus 1, which is fine. That works just fine. It never gets undefined. So now I'm going to do the same process over again, and I'll use the 0. So I have to plug the 0 first into g of x. So that's 3 over 0. And right here, I have a problem. It causes this to become undefined. So in fact, x cannot be 0 because it'll make this undefined. Let's try the last one just to be sure, where I had 3 could not be, x could not be 3. So first thing I plug it into is g of x. 3 over 3 gives me 1. Now that I'm going to plug into f of x. So I get 2 over 1 minus 1, which causes that to go to 0, which means that this cannot be part of the domain either. So these two cannot be part of the domain, but this one can. So I actually only have 2 domain restrictions, just the 0 and the 3. So when I'm writing this out in interval notation, I'll write out negative infinity to 0, and that 0 to 3, and then 3 to infinity. And that should be your final answer.